Hello everyone, good morning.
Good morning, sir.
Morning, sir.
Good morning.
Good morning, sir.
So we'll start in another 1 minute. Meanwhile, anyone who is having any questions, he can let me know because today is your final class on the big data. So today our course will be complete, whether it's big data, Hadoop, Spark. Okay, so that's the first thing. Today we will be working on the Spark machine learning. But one important thing here is that you will be going through one written exam, a program after this class, maybe on Monday or Tuesday, you have to appear for a written exam, a programming exam, which will be on the Spark machine learning or PySpark machine learning. That's why today's class becomes more important. That is your capstone project 3, I should say. Each one of you have to do it individually. Okay. Most probably I'll try to have that written exam on Tuesday, so that on Monday I can have a doubt class for you. So what I would like you all to do is, after today's class, go through PySpark in detail, and on Monday we'll have a doubt class before your exam on Tuesday. Any questions on this, or you are fine with this?
Fine, sir.
Sir, process क्या होगा एग्जाम का एक बार बता दो.
So see, first of all, though, I would like all of you to study over the weekend and come with most of the doubts on Monday. The exam will be like, you will be getting a problem statement and the data set, and it's a machine learning problem. So you have to use any of the machine learning algorithm of your choice, but through PySpark, not through sklearn. And you have to run it in the Databricks notebook. Okay, so you already have the Databricks notebook, so you have to use that and complete it and submit it to me.
Okay, sir.
Okay.
Okay, sir.
Okay, that assignment may also have part 1, which is Hive, related to Hive. So there will be 2 parts. So I am talking about the second part, where you will be using that data set to do machine learning. Okay, but the first part of that assignment will be to load the data in a Hive table and just check whether the data is correctly getting displayed or not. So for those who have the virtual machines, they can do that part on the virtual machine, because Hive is not available on Databricks, right? So the part 1 you can do on the virtual machine, where you can wget that data or download that data, use HDFS DFS commands to move it into Linux, and from Linux to Hadoop, create a Hive table and see if the data is correctly displayed or not. Because we have seen in the past that when you create Hive table, sometimes you see null data, right? Because delimiter is not right or some other issues. So that's the part 1. But those who don't have virtual machine, I'll consider for them, they can only work on the part 2, which is the machine learning part. Okay, I think there are 2 to 3 people only who don't have virtual machines, so it's fine. Any other question on this? Okay.
No, sir.
So that data set will have 2 assignments, or that project will have 2 assignments. One is loading in Hive and verifying whether data is correctly displayed or not. So for that, what you can do, you can just email me the Hive queries that you have used, and the screenshot of the Hive that yes, data is loaded correctly. That you can email me. For the part 2, you can just publish the notebook, Databricks notebook. As I told you, part 2 is the machine learning part, right? So do it on the Databricks notebook, publish it and share me the link of the notebook. That's it.
Okay, sir.
Perfect. So 1 second before I get started. So okay guys, let me share you few links before we move ahead. Yeah, I was not speaking anything, Lokesh. I was just getting these links. So guys, please log into your notebooks if not done. And do let me know if you have any question on PySpark or RDD, data frame, data set, RDD to data frame conversion, data frame to table conversion. Any question on anything? Guys, please ping me if you have any question. So can anyone tell me what is difference between RDD and data frame? I hope I am audible. What is difference between RDD and data frame?
Yes, sir.
Yeah, please.
Yes, sir. You're audible.
Yeah, please let me know what is difference between RDD and data frame.
RDD does not have any columns, and data frames have columns and rows.
Right. So see, as I told you, RDD, first of all, see, RDD is the Spark score object that stores the data. It does not have any schema. That's the biggest thing, right? RDD does not have any schema, whereas data frame has a proper schema. Second thing, you can convert a data frame into a table and run SQL on it. But for RDD, you have to learn a lot of actions and transformations, right? Like map, filter, aggregate by, group by. Getting my point? If you can't answer this question, it will be difficult, right? Can anyone tell me difference between Spark 1 and Spark 2? Spark 1.
Spark 1 consistent
Yes, go ahead.
Spark context, and Spark 2 have Spark suspicion something.
Spark session.
Spark.
Yeah, I don't remember that name.
Correct. So in Spark 1.0, you had only this thing, Spark context and SQL context, but later they added Spark session, which is in Spark 2.0. But Spark 2.0 also have Spark context and SQL context, but we should not use that because of lot of additional benefit that comes with the Spark session, like memory management, thread management. I told you to read. Okay. Anyways, that's fine. And why is Spark better than MapReduce?
Sir, we can do various programming languages on it, like Python and R.
Other than that,
It's using storage part.
Yes, sir, it has
Cache.
memory also, sir, so it's more
Memory,
fast.
memory.
wait, Adhyan, go ahead.
I'm saying it also has memory, so it's more faster than MapReduce.
No, it does not have memory. It uses memory.
Sorry, it uses memory. Yes.
It uses the memory or the cache to store the data, the intermediate temporary data, right?
Yes, sir.
Instead of writing it to disk. Correct? Whereas in MapReduce, it keeps writing to disk. Okay.
Also, sir, it supports both batch and real-time processing in Spark.
Yeah, right. So that was the another thing which I was about to come to, that in MapReduce you can do only batch processing, but in Spark you can do both batch processing as well as real-time processing. So MapReduce is fast. MapReduce supports real-time processing. It uses memory, or it do in-memory processing, right? So these are all the benefits with Spark. Okay. The another benefit is in Spark, you only need Spark to do everything. For example, you do SQL, you do machine learning, everything. But in Hadoop, you have separate tools that you had to learn. For example, MapReduce for processing, Hive for SQL, Scoop for data ingestion, and for machine learning also there was a separate tool. But in Spark, everything can be done at a single place within the notebook. You don't need to access multiple things. You don't need to go to Hive for SQL or Scoop for data ingestion. Spark can do everything from within that notebook. That's a unified analytics platform. Okay, so if you look here in Spark, within this notebook, the Jupyter notebook, I can read a file and do the processing in the form of RDD. If I want, I can use the concepts of data frames. Where are they? Data frames. Yeah, I can create data frames and do the processing using data frames. Data frames, they also have their own functions. Okay, like RDD, they have their functions. Data frame also have their functions. But we don't use data frame functions. Rather, what we do, we convert data frame into table. We convert a data frame into a table. If you see where we have done it, yeah, we convert a data frame into a table, and then we are doing SQL also here. So means we are doing SQL also here. Even machine learning can also be done in the same notebook in a separate cell. So you are not really logging into different tools as you are using in Hadoop. Getting my point? Yes or no?
Yes, sir. Yes, sir.
One second. If you look at Hadoop ecosystem, versus Spark ecosystem, you will see a lot of difference. Huh? See, in Hadoop ecosystem, there were so many different tools that you had to learn. This image is not clear. Huh? One second. Huh. If you look at Hadoop, for Hive, where is Hive? Hive. Yeah, here it is. So when you have to do SQL, you have to use Hive. When you have to do normal processing, you have to use MapReduce, right? MapReduce processing. But in Spark, what you do, if you have to do normal processing in Spark, like the core, you use RDDs. So instead of using MapReduce kind of a thing, you have RDDs. For a Hive, you have data frames. This Mahavat, like on elephant, there is a person who sits on elephant, and we tell him, say him Mahavat in Hindi. So this Mahaut is taken from that Hindi word Mahavat, the elephant rider, you can say. So this is a machine learning thing. If you have to do machine learning in Hadoop, using Java, then we have Mahavat. But you had to write very complex codes. So guys, I am telling you about Hadoop. If someone had to do machine learning in Hadoop, he had to use Mahavat. But now see, in Spark, we have Spark MLlib. So instead of using Mahavat in Hadoop, we will use Spark's MLlib for machine learning using Python. So sometimes in interview, they ask you, in the field of big data, what are all the tools for machine learning? In the field of big data, tools for machine learning. So if you talk about Hadoop or MapReduce, you have Mahavat. In Hadoop or MapReduce, you have Mahavat. In Spark, you have MLlib. So I'm just drawing parallels between Hadoop and Spark, guys. Okay. So these are the important things. So if someone asks you, do you know about Mahavat? Let's see. So this Apache Mahavat is a machine learning thing. I worked on this long time back when PySpark was not that famous. We had to write very complex Java programs. So in the field of big data, if you have to do machine learning, there are multiple options. The first option that came was Apache Mahavat, which was based on Hadoop. So definitely you had to write a lot of Java coding. So Apache Mahavat, it's a distributed machine learning, right? All of you so far have done machine learning on single machine using sklearn or R packages. But now we are talking about big data, means distributed machine learning. It's a distributed machine learning system. It uses GPU, CPU, whatever. Okay, so we have Apache Mahavat. So you can see the algorithms, what all algorithms it supports, what all regression algorithms it support, clustering algorithms it support, classification algorithms, recommendation engines. Okay, distributed linear algebra, if you have to do matrix algorithms kind of things. So guys, I would like all of you to give 5 minutes to yourself. Go through this website. I'm pinging you the link. Go through this, click on these things, and read about what is there in distributed linear algebra, preprocessors like feature engineering. Please take 5 minutes, explore this page under algorithms. Done. Have you explored it a bit? And are you able to understand the terms written? OLS, ridge regression, Cochrane-Orcutt procedure, Durbin-Watson test. Anyone who know what is Durbin-Watson test? Anyone who know what is stochastic? What is non-stochastic solutions?
So Durbin-Watson test is used to check the autocorrelation.
Between for which algorithm?
So linear.
Linear regression or something time series forecasting,
Yes, the time series forecasting times.
right? So they are giving you see how this is done in R versus how this is to be done in Apache Mahavat. So Durbin-Watson test is there, right? So you just need to have a look at these things. Clustering algorithms, so canopy clustering, distance matrix. There are different kind of clustering algorithms, right? Hierarchical clustering, right? Center-based clustering or centroid-based clustering. What are different distance metrics? Can anyone tell me? In the clustering algorithm, what are the different? Yes.
Manhattan, Euclidean.
Yes, very good.
One more.
Mahalanobis, Euclidean, Manhattan, and Mahalanobis. Mahalanobis. Anyone know who is Mahalanobis? Who was Mahalanobis?
Father of statistics.
Father of statistics, as in where? Globally or in a particular country?
So that globally, I think.
And what was his country of origin?
I think,
That's the biggest problem. Not for you guys, but with the education system. Mahalanobis was PC Mahalanobis, Prakash Chandra Mahalanobis. He is the father of statistics in India. The Indian Statistical Institute was founded by him. Okay, so PC Mahalanobis, Prakash Chandra Mahalanobis is the father of Indian statistics. He is the founder of Indian Statistical Institute, and his distance formula is far better than any other distance formula. So Euclidean, Manhattan, these are very basic distance algorithms. PC Mahalanobis distance algorithm is far complex and accurate as compared to all others, but people don't use it because it is complex. Okay, so please have at least knowledge about these things. Okay. So yeah. So we use a lot of distance algorithms. Those distance algorithms were for the numerical data, but if you have categorical data, we have different distance algorithms like cosine similarity. Okay. So please, what I request you all to explore this Mahavat thing. Don't go into this because this is about Java. This is about MapReduce. We have moved out of Java and MapReduce, right? That's why we are doing Spark. So we will talk about it. But if you go to its developer guide, not developers, release community download. One second. So what have been done over the past few years is Mahavat also supports Scala now. So it supports both now, Java as well as Scala. Earlier it only supported Java, but now it supports Java and Scala also. But that does not mean that people uses it. I'm just telling you. So Samsara is its language. The Scala language for Mahavat, it's Samsara. They have just given it a name. Okay. And like we have DAGs in Spark and other systems. So here also they have some concepts of DAGs, logical DAGs, physical DAGs, but directed acyclic graphs. Can anyone tell me what is this operation? Can anyone tell me what is this operation mathematically? A to the power T and A.
Transpose.
A transpose A. So what is happening between A transpose and A? A multiplication or dot product.
After A transposition, it's multiplied with A.
Yeah, it's a dot product with A. A transpose A. And what is transpose operation?
Rows converted
Changing
into
to
columns.
column
Rows
interchange.
to, yeah, rows to columns, columns to rows. Yes, correct, Shivali and Madhu. Perfect. I'll just quickly show you one program, okay? They are also working to support Mahavat with Spark, but you don't go into that. Mahavat was particularly for Java MapReduce, but now they are working so as to support Mahavat for Spark also, so that we can use Mahavat in Spark also. But you don't need to go into that. We are not going to use Mahavat with Spark.
Sir, we can use Mahavat in Apache means this PySpark.
That's what I'm saying, that Mahavat developers are working to make it compatible with Spark also, means people can use it with Spark also, but with a very limited support. Maybe very few algorithms are there which can be used with Mahavat and Spark. You cannot use all the algorithms.
Okay, okay.
So remember why I am telling you Apache Mahavat is because Apache Mahavat was the first, one of the first distributed machine learning system which was introduced with Hadoop, not with the Spark. It didn't come with Spark. Abhi recently they have started to support Mahavat with Spark, but leave it. Okay. So the power of Mahavat is that it allows you to quickly work on the distributed machine learning algorithms. Okay. Distributed machine learning algorithms using Java and Scala. So when you have to run a machine learning algorithm on 10 machines parallelly, so as to get better, faster performance, so you use this. So distributed machine learning is primarily the thing that we are discussing today. Instead of machine learning on a single machine, we are doing distributed machine learning. Can anyone tell me what are the benefits of distributed machine learning?
Yes, sir. It's run fast and we have big data, then it's easily give predictions.
I am not yet looking for that answer. I need a better answer. Anyone?
So fetching of large data can be easier.
In machine learning, do we really fetch data?
No, so like reading of data.
Why we read data?
So to work upon any project or any work, so
No.
any analytics. So.
Sir, it's
Sir, it is-
understand the
sir-
data
Wait.
more,
Adhyan, go ahead.
So it is fault tolerant.
Okay, but still you guys are missing something.
Using for unstructured data easily build a model.
That is also fine, but you are not coming to the right answer that whether you're talking about training or testing. What is improving here? You all are saying it is faster. What is faster? The training of the model
Training.
is faster or
Training.
testing is
Training.
faster?
Training.
So training.
Right, your answer should have very proper words, right? You are saying it is faster. What is faster? So training a model is faster. Okay. Similarly, predictions are also faster. So let's first understand the distributed machine learning before talking about these things. Let's say you have a machine learning model, you have a ML model, and you were running it on a single machine, right? And let's say you had 10 terabytes of data. 10 terabytes of data, trained data, I'm saying. So first of all, understand that you have 10 terabytes of training data, which was going into model running on a single machine. It may take 10 hours to train it. Correct? But when this 10 terabyte of data is stored on a distributed system, let's say you have a cluster, Spark cluster or Hadoop cluster, whatever, with 10 machines. Let's say you have 10 machines, each machine having 1 terabyte of data. Each machine having 1 terabyte of data. Then that same model is getting trained here also, here also, here also. Parallelly, the training phase is running parallelly on 10 machines, each processing only 1 terabyte of data. And finally, you will get the combined output from all the models once they all are trained. So you will get finally a single trained model. But initially the training will happen parallelly. So model is learning parallelly on 10 different machines. So now if this ML model or this copy of your model is running on 1 terabyte of data, it may complete in 1 hour. All of them are just processing 1 terabyte of data. All of them can process in 1 hour. So how much will be the total time taken by the model in training phase?
1 hour.
1
1
hour.
hour, right? Not 10 hours. So that means using distributed machine learning, you can train a model on huge data. That's what it is, big data. That is the first thing. And second, in a lesser time. Because on this machine, single machine, it may happen that while processing 10 terabyte of data, your system crash. It can crash also. Out of memory issue, your RAM is limited. If you have your personal laptop and you run a 10 terabyte of training data, your system may hang. It may fail because of memory issues or other issues, right? So the first problem is your system can crash. Here it will not crash, whether you give it total 10 terabyte of data or 100 terabyte of data. Second, here, let's say it does not crash, but it take 10 hours time. Here it completing in 1 hour. So we're getting two benefits. You can increase the volume of data as much as you want, plus the time is not getting increased. Time is getting decreased as compared to a single machine. So that's why today everyone is talking about distributed machine learning, not a standalone machine learning. Getting my point? Yes, no?
Yes, sir.
Yes, sir.
Okay. Okay, so today everyone needs to know what is distributed machine learning and what are the ways of doing it. So Apache Mahavat is one of the way to do distributed machine learning. It supports both Java and Scala, but it uses MapReduce, due to which it is slow. So now they are also trying to move this to Spark also, because if Mahavat will move to Spark, it will be fast because Spark itself is very fast, right? So guys, understand, Mahavat used to run on MapReduce earlier, due to which it was slow. But now they are also having Mahavat running on Spark, due to which it is becoming faster. Okay, but the data science community haven't adopted Apache Mahavat to that level. So Apache Mahavat people don't use much. Even if it is moving to Spark also, people don't use. Because Spark say, hey, why you want to use Apache Mahavat? I am giving you my own machine learning library, na, MLlib. Spark has its own machine learning library. So let's use Spark's machine learning library, na. Why you want to use Apache Mahavat? Because Apache Mahavat was initially built for MapReduce. Now they are making it compatible with Spark, but still it is not meant for Spark, right? Okay. So as I told you, Spark is faster because of in-memory processing. It uses a lot of in-memory processing. And second, because of this distributed nature. These are the answer.
Even if Mahavati will not use in data science, if data science people will not adapt Mahavati, it is not using anywhere else.
Yeah, that's what I'm saying. Apache Mahavat is being used by maybe 2-3% of the people who are working on distributed machine learning. So in the field of distributed machine learning, Apache Mahavat is not adopted that much. So whenever I say distributed machine learning means machine learning on a cluster. So Apache Mahavat is not that used. It may be used by 5-6% people maximum, but 90% of the people uses Spark MLlib, Spark's own machine learning system, not Apache Mahavat. Okay. Whenever you see any variable being declared as val, that is a Scala, actually Scala programming language, just for your knowledge. Whenever you see this word val, na, that is a Scala programming language. So here this guy is using a OLS model and fitting it on the X and the Y data set. What is OLS model, guys? What is OLS model? Ordinary least squares.
Where our target has to be minimize the error
It is used for regression or classification.
regression.
So it's nothing but a linear regression model, right? So it's a linear regression model where the target is numerical and right, you're correct. Least squares means we are looking towards the least errors, decreasing the errors in prediction. So it's ordinary least squares. And then this is how the outputs looks like: coefficients, estimates, standard errors, t-score, right? Anyone who know what is t-score? You must have worked on R also, Python also. Once you do linear regression model, you print the summary of the linear model. You must have seen Z score and T score, right? Have you seen the Z score and the T score? Z as in Z, Z score and T score? Yes or no?
Yes, sir.
Yes, sir.
Yes,
What
sir.
is Z score there and what is T score there?
The t-score is standard deviation.
Not standard deviation, it is T distributed score, T distribution. You know, it's kind of a distribution, not standard distribution. It's a distribution. Or okay, if you say standard distribution, I will take it. Okay, that's correct. But can you elaborate more? Why the word T? Why the word T here?
So because we use t-test in this case to compare how the result differ from the average mean. Or
Absolutely correct. You're right. So it's a standard distribution, not a standard deviation. Yeah, you're right. Standard distribution, and it's a t-test that we do there. Then we have a Z score, which is we do Z test. Then we
Yes.
have a F test, right? Different scores, right?
Yes, sir.
So remember, they can ask you in interview difference between a T test, Z test, and a F test. So you should be aware about it. Okay. Anyways, so that's fine. We are not going into Apache Mahavat that much. So let's move to the next thing, H2. Anyone know what is H2O? Guys, what is H2O?
Water.
Correct. That's what I was expecting at least. H2O is water, but have you heard about this H2O? So see, H2O is an organization which builds machine learning models. They have optimized them. So H2O, you can say, is another library, like you have sklearn, right? So like you use sklearn, you can use H2O also. In Python, like you use H2O, you use sklearn, you can use H2O also. It's another package. And this package also contains all the models. Like sklearn contains a linear regression, logistic regression, everything H2O also contains. But H2O models are mathematically more efficient. What I'm saying is, in Python, instead of using sklearn, if you use H2O package, the same model will perform faster because of lot of optimizations that this company has done. H2O is an organization which have optimized the processing for machine learning models and made them faster. They don't build any models. What they do is they improve the performance of the model by changing the mathematical formula and the mathematical computations behind the scene. So they have worked a lot on these things. Okay, H2O is one of the market leaders in the field of machine learning. You can go through their fraud detection use cases, customer churn prediction, credit risk scoring. So it's again another famous organization in this field. So when I talk about H2O, let's see this. So H2O gives you the Python module also. So as he's saying, hey, why one should use H2O over sklearn? Because sklearn makes things mathematically better. So if you want to do machine learning with Python, so instead of sklearn, you can also use H2O. So Python can support H2O also. So see what you have to do. Simply you have to, instead of importing sklearn, you will import H2O. And from H2O.estimators, you want a GLM, which is a linear model, generalized linear model, GBM, which is a gradient boosting model, random forest model. So you guys can do that today after the class if you want, or over the weekend. Instead of sklearn, try to use H2O. Okay. So guys, any questions so far?
You said H2O is a platform, right?
What? Sorry, your voice is not clear.
H2O is a platform, you said. No?
Yes.
We can use it as a coding also.
No, your voice is not clear. Sorry. What do you want to say?
How can we use it in coding?
In your coding?
Yeah, you are showing no H2O from a H2O.
So I still didn't get your point because it's just a package, right? So you use that package, that's it, it's done. Like you use sklearn, you use H2O.
Okay.
Let's say the coding will be also different or just a package only.
See,
like
what coding you do
the
in
further coding,
sklearn?
like we write about the program, like importing, like evaluation of data set, like ED process. So the whole coding will be same, but only this package name will be different, right?
So you guys don't really do coding, I would say. Okay, you just use methods, you just use functions. Okay. So you don't do coding, you use functions. Okay, all these in Python, what you are doing, you're not really coding anything, you're using the functions. So just the function names will change, guys. When you talk about coding, actually that's a really different thing. You're writing functions, you're writing classes. So what you normally do, you say, okay, dot fit, dot predict, or maybe standard scalar dot fit. So you really just use the functions, right? So the function names will change, that's it. So you really don't need to worry about anything. Coding is still same because you are doing Python coding. If you say coding, coding will not change because let's say you are talking about Python, you have to write a for loop, that's a coding. So writing a for loop is still same. So coding is not changing. The way you used to write for loop, it will be there. The way you used to write a class or a function, it is there. So the coding is not changing, only the functions will change. So if you had a fit function, it may be a train function. If you had a predict function, it may be a predict. Instead of predict, you may have a evaluate function. Function names will change. Even the hyperparameters will remain same. Nothing will change. Only the function names will change, not even the coding. See, anything is changing here. Correlation heat map is like that only. As you used to have, you are using SNS. Can anyone tell me which is SNS package?
Seaborn.
The seaborn.
Seaborn, very good.
T-bone for plotting.
Seaborn, very good. See, you used to split the data maybe using some function, a train test split. Here you are using split frame. So only the function names are changing, but the concepts are still same. A random state and the ratio 60 to 20% ratio. Okay, so nothing is changing, just the function names. Normally use extreme gradient boosting. Here it's H2O gradient boosting estimator. After that it's same. You used to do dot fit, here dot train, but you are passing predictors, the response and the frame, data frame. Okay, so your coding is not changing, just the function names are changing. Is it making sense?
Yes, sir.
Yes, sir.
Okay, no, good. Please clarify your doubts immediately as you have. Like here he is creating a gradient boosting estimator. He is having some hyperparameters. None of these
Or is it
hyperparameters.
increase the accuracy or only speed, sir?
Both. It improves the
Accuracy and
speed, but primarily it's for speed. Because they have they have done a lot of mathematical optimizations behind the scene. Like instead of using a dense matrix, they use sparse matrix or some that kind of things. But they, H2O as a company, haven't given any new models. They have optimized the existing models by changing the mathematical computation framework behind the scene. So they don't change the accuracy, improve the accuracy, they improve the performance. But sometimes accuracy may or may not get improved. So, but accuracy will not decrease at least. Okay. But their prime focus is not accuracy, it's performance. Provided they don't compromise on the accuracy. Like, okay, with sklearn I was getting 90% accuracy, with H2O I am getting 60% accuracy. No, that will not happen. If you are getting 90% with sklearn, you may get 89 or 91 with H2O. A plus minus of 1%, but not bigger degrees. And that also you can improve by changing the hyperparameters. Now let's see. This is a gradient boosting model, an ensemble model, a boosting model. N trees 3000. It's using 3000 trees. Learning rate, stopping rounds, stopping metric, which is area under the curve. Some columns, sample rate, row level, seed. So all these are quite understood parameters that you already have done. But yes, it may happen that earlier it was like alpha in sklearn. Let's see that. Yeah. So in sklearn you also have learning parameter. Here also you have learning rate. There, here you have entries. There you had what, n estimators. So there you had criteria, stopping criteria. Here you have stopping metric, AUC, area under the curve. So there you have min split, min sample, and all those kind of things. So there also you have all these things. Well, here it's limited parameters. You have all the other parameters also. You used to do grid search CV. Guys, have you done grid search CV?
Yes, sir.
So here also
Yes, sir.
see, you have grid search CV. Can anyone tell me? Can anyone tell me what is happening in this grid search CV?
Sir, it chooses the best parameter, like from maximum depth, it's a loop. It will work in a loop. It will choose which fit the best to the model.
Who is this? Neha, right? Hello, who was this? Shivali or Neha?
Neha, sir.
Yeah. So Neha, absolutely correct. So see, what we are trying to do is for this GBM model, for this GBM model, we are not sure what should be the max depth parameter for this. Should we keep 4, 6, 8, 10, 12? So we are trying 5 different options for this GBM model. So for this GBM grid, which is this GBM grid, the GBM model, we are passing all these hyperparameters. So grid search CV will run this model first for max depth 4, then 6, then 8, then 10, and 12, and see based on some internal strategy or criteria, which one of them is best, and tells you the accuracy for all of them. So it tells you out of this max depth, which is ideally the best for you. And you don't need to really do anything. It's the same concept in sklearn also. Just few words are changed, function names are changed, nothing else. Some parameter names are different, but everything is same. So in sklearn grid search CV, you also have an estimator and then parameter grid, right? So here also this was your estimator, this was your estimator or the model, and this was your parameter grid, which is a depth grid. Okay. So there is nothing new here. I just want to tell you, but I want you guys to know about these things. You will not get these things somewhere easily. So when you go to H2O website, guys, when you go to H2O website, you can use their R coding Python, or so H2O supports both R and Python. So H2O supports both R and Python. You will get the examples also, that see how it's importing the file. So even instead of pandas, you can use import file option to read a file. Okay, this is important. Just first line, initializing the H2O. That's what you do. This is another grid that 4 grids are getting created, and this model will run on those grids. And then you'll train it. And for each grid, you'll get the AUC score. And anyways, that's not a big deal. It's a simple thing. So now in interview, if someone asks you about Mahavat or H2O, you should be aware about. Okay. So now that's it. What we will be doing now is moving into the Spark machine learning. Okay. I have shared with you 2 links for Spark machine learning. But any question before we now move? So we talked about distributed machine learning using Mahavat. We talked about Python, that instead of sklearn, you can also use H2O, which is better and faster. So instead of sklearn, which is running on your single machine, you can use H2O also. H2O also supports distributed machine learning, but we are not talking about it. But H2O supports both. Standalone laptop पे भी चला सकते हो, or you can run it on the distributed cluster also. Okay, so H2O is working a lot on lot of different areas. But now our target is to look at the third and the most important framework, which is Spark's machine learning framework, which is the best till date in terms of distributed machine learning. Okay, But I told you that Spark gives you two options, Spark ML lib and Spark ML. Spark ML lib. So Spark gives you two options to do machine learning. Uh, uh, Spark machine learning library, which uses RDDs. See, it's a RDD based API or RDD based solution. And now it's in the maintenance mode. When something is in the maintenance mode means now they are no more actively developing it. They are not focusing much on this. So Spark is not focusing much on the ML lib. What they are focusing on is ML. Spark ML is the new package introduced in Spark 1.2, which is better. Okay. So instead of spark.ml lib, we will be using spark.ml. So going forward, they may not contribute much to the ML lib, rather to the ML package. So these are two different packages, like sklearn is a package, H2O is a package. These are different packages. So in Spark, we have ML lib and ML2 packages. We have all models in this package also, all models in this package also. But we will be using this because of the data frame. We will see how to work with data sets, how to work with algorithms, how to create pipelines, and that's it. Any question? So I yesterday told about the pipeline, ML pipeline, which is nothing but containing multiple steps, starting from data cleaning to model training to model evaluation and then deployment, all these things. So this is how a pipeline looks like. You have some raw data, whatever data you have, you may be doing some tokenization, hashing, though don't worry about this, what it is, I'll talk about it. But whatever you are doing, the ultimate purpose is to get the features, feature vectors. I'll explain you what is a feature vector. So here, the most important thing is getting to the feature vector. That's what we are going to study today. Then we'll pass the feature vectors to the model, logistic regression model. Okay. One second, guys. Hello. Okay, guys. Yeah, sorry, got a call. Okay, Spark ML. Yes, Pankaj, Spark ML supports R also, R programming language also. Okay, so guys, what I am talking about the feature vectors, not about tokenizer, hashing TF. This is not important. Important is this feature vectors. We'll talk about it. Here you will see the programs written in Scala and Java. I'll share you the link for Python also. So here, if you go at the top now, if you go at the top API documentation, you will see the Python documentation also. So whenever you are on the Spark website, first of all, see the Spark version. So first of all, this is a very old version, Spark 1.2. We are working on Spark 3, right? So ideally, this page is not a latest page, but for your reference, I'm telling you, just always check the Spark version here, and always from the API documents, click on the Python if you are interested in Python. So there you will get the Spark's Python documentation. But as I told you, this is MLlib. This is all MLlib. So here some logistic regression model is being used. They are training it. Okay. So we are importing from pyspark.mllib.classification some classification model. Okay. But as I told you, see what it's doing parallelize. Parallelize is to create an RDD. So this is an RDD based operation and then prediction. So it predicted the output. So it's a very simple thing, but this is all about the MLlib. Let me ping you this. So my point to all of you is, in Spark, have a look at the Spark's MLlib library also, which is primarily work on RDDs, right? Parallelize and all these are RDD kind of operations. See the collect function. This collect function is a RDD function, right? But we are not working on it. Plus, always check the Spark version 1.2, very old. We are on 3 or at least 2. So please have idea about it whenever you are studying and Googling it. Okay. We have a lot of feature engineering like normalizer, standard scaler, everything is available. So I'm closing this page because I will not talk about MLlib. I will talk about ML. Okay. So, oh, where did that go? Anyways, so this is again MLlib, but in MLlib, you can study about, see, the previous page was also for MLlib, but version 1. This is version 3. So ideally, this is how you should be seeing. This is Spark's 3 page. Here, if you go to API documentation, you have Scala, Java, Python, and R also. If someone wants to do R on Spark, they can do that also. Everything is possible. But you, okay, okay, come back here. So let's click on Python. So you will come to the PySpark documentation, and here you can search on like what you're interested in, like MLlib, and you can study about that. Okay, so what I'm telling you is Spark 3. This is the link for MLlib. Okay, so MLlib is a RDD based API guide. We won't be using it. Okay, so what we will be doing is Spark ML. So let's see Spark ML user guide. This is again Spark ML, but with 1.2, which is older. So I don't want this. Sometimes it always takes you to the ML lib, which is not good. This is PySpark 2, at least, yeah, this is PySpark 2. And here you see the PySpark ML and the classification model. So you can go through, if you guys understand Python, if you guys understand Python to some extent, let me explain you what is this page. What this PySpark.ml.classification, this code is showing is all the classification models which are available in PySpark. Okay, so I am talking about PySpark. I'm talking about ML, not MLlib. This is Spark version 2, not 1 or 3. Remember these things, very important, always. And now we are talking not about regression models, but the classification models. So what are all the classification models that are available in PySpark's ML package, the data frame wala package? So if you go, so it's doing some PySpark coding, definitely some PySpark coding. See, all tells you all the models. Logistic regression is available. Logistic regression model, its summary. All, yeah, you have decision tree model. You have a GBT, gradient boosting tree model, random forest model. You have naive bias. You have multi-layer perceptron, which is a neural network. You have OVO and OVR. Remember, one versus rest, one versus this. This is also one of the model, OVR. This is a class, a Java, not a Java class, sorry, a Python class. This is a Python class that is getting created. This is how we create classes in Python. And I hope you know how to create a function in Python, def function, self. So now what we are doing, we are going inside the logistic regression. So how the logistic regression model looks like. So this is your logistic regression model here in Python. And it's the code here for the logistic regression model. Here in this init method, it's showing you some of the hyperparameters for this model. Feature columns, label columns that you will pass, maximum iterations, regularization parameter, L1, L2 regularization, elastic net, this is also regularization, tolerance level, fit intercept, thresholds, probability. So whether standardization is there or not. Okay, so this is about the logistic regression model. Let me go inside another model, which is, let's say, decision tree. So if you go inside the decision tree classifier or the decision tree model, we will go inside its init method. Those who know Java, init method is like constructor. So init method in decision tree, what we are passing, decision tree hyperparameters, maximum bins, information gain, right? The maximum depth, impurity, whether it's Guinea impurity, right? Seed. So this is how this particular model looks like. Let go inside the random forest. In the random forest model, go inside its init method. You will see number of predictors here. Where is it? Number of predictors or number of trees is 20 by default. So by default, there are 20 trees in the random forest model here in PySpark. So what I want all of you, please take 5 minutes, guys. Explore this page, please. I can keep talking about it. It won't make sense. What I'm saying, just Control F on this page and search for the model you are interested in. Let's say you are interested in naive bias. So search for naive bias. You will see the naive bias class implementation. Within that class, go inside the init method. The init method will contain its hyperparameters. What are all the hyperparameters? Smoothing parameter, weighting, model type, whether it's multinomial classification, binomial classification. Please take 5 minutes. Go through all the models and their hyperparameters, please. And confirm me once we have gone through all of them. At least try to understand what is written there. They have explained also smoothing, the smoothing parameters should be greater than 0. Everything is explained. Just read about it. So I give you 5 minutes, please. So guys, those who have gone through the PySpark classification package, they can go through PySpark's regression package as well and see which all regression models are available. Please have a look, because we will be implementing one of the models from these now. So just go through these.
One question.
1 second. You may not be aware about isotonic regression, so don't worry. Whatever you know, regression, about this thing, random forest, just go through that and see their hyperparameters. Okay. 1 minute. Okay. Yes, please tell me, Pankaj.
Like so these, I've seen some models like having hyperparameters have very definite values, and so these models will work for every kind of data set. Like for classification I'm doing, so whatever will be the data set there, it will properly, like it is already defining a particular model in some cases, like we're using hyperparameters. So here it is putting the values also, like yeah.
No, sorry, I didn't get your point.
Like so in classification, the hyperparameters were already predefined. Like this has to be taken.
Yes.
So, like if the data set, like the data set might be like different kind of thing. So these models which are already been defined, are they will suitable for that data sets also, which are different, or all I want to like that how the accuracy will be differ, like will be fine for every data set.
See, first of all, the models are specific to the data set, right? Means
Yes, sir. Yes, sir. Yes. That's what I am saying.
no. What I'm saying is, if it's a regression data, so you can use any regression model. If it's a classification data, you can use any classification model.
Yes, sir.
None of the classification model will say no, we will not use this data.
Yes, sir.
So what is the problem? So if you have a data where you have a target as a categorical predictor, you can use any classification model.
Like sir, in
Huh.
like in the defining in it, the maximum depth is defined as equal to 5. Okay, so the that whatever model I'm using, like it is a random forest, so the maximum depth will be go for the 5 only, not for extend beyond 5.
Absolutely,
So
absolutely.
this is what I'm asking. Like we are predefining the model, or like it will go the for maximum depth it will be taken as a 5 only.
So
But
how did sklearn work? Can you tell me? In sklearn, don't you have any predefined values?
yes, sir, we have.
So same is the case here. Then how is it different?
Like sir, I just want to know about the like different kind of data sets, so we can change the hyperparameter there also, no?
Yes, absolutely.
Oh,
No, because you yourself is answering the question. Because if I talk about sklearn and I talk about, let's say, random forest. So even sklearn random forest, if I talk about where is that number of trees, number of estimators, here also you have 100 by default. But you can change it. No one stops you from changing it. You have even min split, min bucket, max depth. So let's say max depth is not there. You can set it. But there are things which are preset. You can change it. No one stops you from changing it. If you don't change it, it will use the default. Same is the case here. For each
okay.
model, there will be some hyperparameters, and for each hyperparameter, there must be some predefined values. You have to change it because definitely on one data set, it may need a higher depth. So you have to change it.
Okay. Yes.
Right. But if you had any other question, tell me, matlab, if.
No, sir, it's fine.
No, so hyperparameters are always have some prefit values. You have to change it.
Okay.
You have to change it. So please go through this regression model also, regression estimator also. In your free time, you can go through it. So what now we will be doing, we will be using those packages that we just saw. Within ML, we saw a classification and regression package. So guys, all of you start your cluster. Or maybe create a cluster. So while the cluster is starting, what we will do, we go to the notebooks, we'll say create new notebook. Let's say today we are talking about doing a regression. Now here you can change whether you want to do it through R or Python. So those of you who want to practice R, they can also do that in Spark. You want to do through that Scala, Java, you can do that. But we will be doing Python. So this notebook is created. Ideally, I would tell you, ideally, any of the sklearn model that you guys have already, you must have a lot of sklearn models that you have. You can convert all of them to sklearn. Oh, sorry, all of them to PySpark. All the sklearn models that whatever you have done so far, all these notebooks, they can be run on the Spark cluster also, provided you have to do some changes. Wherever you are importing sklearn, you have to change it to pyspark.ml package, plus some function names will change, right? As someone was asking previously also. The only thing is no coding change. You don't need to change your code. You just need to change the function names or maybe the name of the packages. But if you have written any functions, loops, all those will still remain the same. Okay. Okay. So this is getting started. Once this is done, you will start to say import pyspark.ml. So you are now not using sklearn, okay? No sklearn. Pyspark.ml dot, let's say, regression. So from this, you will say import. Now let the cluster start. Then here I can say import linear regression. If you don't know the model name, you can come here and check the model name, linear regression. I shared with you these links, right? Within pyspark.ml, which are all regression models and which are all classification models. If you go to this variable, they have created a list of all the models. You want linear regression, just right here, linear regression, like this. Okay. So please, all of you, start the cluster, create a Python notebook, and in that, please run this. Run this and let me know if it is done. Oh, great. I don't know why it's slow for me.
Done, sir.
Good, good, good. But let's say you don't know in this how many models are available. So you can say control and space. Just click on control and space button. It will show you a drop down of all the models. Please do that. After import, just press control and space and see a drop down will come. My cluster is not yet started, so I can't show that. Is it coming? The list is coming.
Yes, sir.
Perfect. So you can import multiple models like this if you want, like a decision tree also. So you can do that. Yeah, so now my cluster is started. So you see all the list. whichever model you want. There are some extra things, they are not models, so ignore them. Like you're seeing Spark session, Spark variables, everything is coming. Ignore those. So you just type the word and it will come. Like you say D and then it will say decision tree regression. Okay. And now everything is same. Okay. After that, let's say you want linear regression. You create an object of linear regression like this, right? This is how you used to do this. And let's run it. Model is created, LR, and see the variable. It's showing you, see, the linear regression. It's a linear regression model. So when you are doing regression and you create an object for linear regression, just use this params keyword to see all the hyperparameters. So the hyperparameters that you have is the first one is not of relevance, ignore it. Second one, which is yes, which is elastic net parameter, epsilon parameter. Okay, then you have feature columns, fit intercept, loss. So you can look about the hyperparameters which are of interest, like maximum iteration. I don't know why this aggregation depth is here. Suggested depth for tree aggregate. So leave it. Don't worry about that. So you have something like memory, system memory related things. Again, these are not related to model. This is related to the data which you are storing in memory. So some are hyperparameters for the model and some are related to Spark. So you just focus on the Spark ones, right? Elastic net parameter, anyone who knows what it is?
The regularization,
Yeah.
hybrid of both the raise and lasso.
Very good, very good. Elastic net is L1 plus L2, right? Both L1 regularization and L2 regularization. Ridge plus lasso. Correct. Okay. So once you have done and looked at it, the next step that comes is LR dot, I think fit. Yeah. You have LR dot fit, where you pass X and Y. That's what your model is. So we don't have data so far. We'll create the data, then I'll put it here. Once it's fit, you will LR dot okay. What I had to do is I need to pass it on to a model. I think some model. I'll do it, but I'm just telling you. Then I'll say model dot evaluate. Evaluate as in scoring the model. This will be your test data, test of X and test of Y to evaluate the model. So we'll do, the cycle is same. Okay, don't worry about it. You fit it, evaluate it, you fit it, evaluate it, and then that's it. You get the model. After that, we can check RMSE, MSC, or accuracy of the model. Any question in these steps? We will be following these steps, but any question? We will be seeing a model, looking at it, parameters or hyperparameters, fitting the model on the train and test data. So this is fitting the model on the train data. Let's say you're fitting it on the train data. Then you are evaluating it on the test data. Okay. If you want, you can further check RMSE, MSC accuracy of the model and plot the graphs. So we will see all these things. Any question in this step?
No, sir.
Good. Okay. But there is one thing that you will be given the data, initially data. So you have to convert this data into X, Y. I hope all of you understand that, right? Whatever data will be given to you, you will be splitting it into features and target, right?
Yes, sir.
From X, what you will get is train of X. Sorry, you have to get train of X and test of X, and then you have to also get train of Y and test of Y from Y, right? All of you, I hope no questions, no doubts.
Yes, sir.
This is the standard process that we do. Nothing is changing. So even your existing sklearn program, you can copy paste here and run it, but the function names will change, how you are importing or fitting and all. Huh? Okay. Definitely, this data that you are splitting into all these things, even before doing all these splits on the data, which is nothing but your file. Let's say you have a data file, maybe a Titanic data, whatever. You will first do EDA, right? So that's it. Whatever data file you will have, you will load it into a data frame, guys. Understand it. I'll say, hey, this is a data file. So what you will do, you will create a data frame. How will you create a data frame? Spark session dot read dot csv path of this data file. Let's say this data file dot csv. And you will do EDA on this data frame. That's it. Getting my point? So whatever you have learned so far is going to be used in Spark. So this is how we were creating data frame, guys. Yes or no?
Yes, sir.
So we are done. So whenever I'll give you a file, you can first upload it using that data section, right? And then you give the path of that file here and you will get a data frame. I want to ask you guys one question. I could have done this also, pd.read csv. Why I could have used this also. Why I'm not using this and why I'm using this? Can anyone tell me?
It will be
Not be a
distributed.
They're
file.
distributed parallelly.
Wait. Yeah, Lokesh, go ahead.
Sir, it will be distributed parallelly and we can process multiple queries.
Correct. Yes. So this is a standalone data frame, a pandas data frame, but this is a Sparks distributed data frame, right? So that's what the purpose of this step. Then we'll do EDA and all this stuff. Let me just publish this notebook. I haven't done anything in this, just steps. So I'm pinging you. We'll take a break, guys. I'm pinging you this. Just see the steps, nothing else. So we'll connect at 1:05. Okay.
Okay, sir.
We'll connect at 1:05, guys. Please be back after 11 minutes. Okay, guys, please confirm me if you're back. Okay, good. So far, I hope you are now aware. It's a simple process. Just the package and the function names are different. Everything else is same. How to read the file is different. Instead of pandas, we will be using Spark data frame. Yes. Okay, perfect. So now let's look at a particular thing. So I already have this binary classification. Let me open this. Okay, so I already have a data set where this is a bank data, where bank wants to decide whether to give loan to a particular person or not. That was one data. Let's see which data set it is. Deposit, yes or no. Okay. Yeah, this is a different data. So as you all know that there can be multiple scenarios. Let's say this is a bank data. In this particular case, we want to see whether a person will open a fixed deposit or not, whether he will open a deposit account with us or not. That's what the data is. Okay. So first of all, here we are not talking about regression. We are talking about classification problem, whether we should give loan to someone or not, whether someone will open a fixed deposit or not, that kind of a problem. So that is our data set. So let me get this data bank CSV file. So the very first step that all of you need to do is read this file, spark.read.csv, or rather this option which I told you last time also. We will read this file. So but first you need this file, right? To read you need this file. So let me check on Google from where did I got this file. I don't know if it is the same data set or not, but we will download a new data set if we don't get this. So what I'm doing is I'm sharing with you this link. Please download this data on your local. First, you need to download this data on your local and then upload it on the Databricks. So please do that. So the problem statement here is, given the details of a person, whether he will open a fixed deposit with us or not. Banking domain is one of the widely growing domain. Okay. And a lot of machine learning is used in the banking domain today. So let me upload this file. All of you also please upload the file. You can upload files here up till I think 50 MB or few GBs, but after that it may become slow, but you can try because it's a free cluster, no? That's why. So have a look here, guys. This is another important thing that I want to tell you. So far, I told you whenever you upload a file, you get the file path, right? Which is like a HDFS path or a DBFS path here. But the good thing about Databricks is Databricks parallelly create a table also for you. A table also. Consider it like a Hive table. It's not a Hive table, but Databricks also create a table for you. This is Spark's internal table. Spark keeps it with itself, but consider it like a Hive table. So you can change the name of this table if you want, let's say bank info. What database you want it to be in, like in Hive also you used to have database. File is CSV, comma delimited file. First row is the header. So, and then create table. So this bank info table will also gets created for you automatically. So that's the another benefit of Spark, this Databricks, that when you upload a file, it automatically creates a table also for you. So if you go to data, you will see the databases. Under default database, you have a bank info table. So you have a file also. If you so you uploaded a file, parallelly you have a table also. Now go back to your notebook, whatever notebook you had. So guys, see the file that you uploaded, the file that you just uploaded, you can definitely access it now. I have told this multiple times. The file you just uploaded, you can read it, spark.read.format, CSV for schema, file store, tables, let's say star. Data frame dot show, or if you don't want to use show, you have display the data frame, right? Display the data frame. Oh, for me, there was some other file. Okay. When I say star, what happened? All the files in this path got uploaded. So let me check the file which I uploaded. I forgot the name of the file. bank-3.csv. Because I already had that FIFA wala data, no, which I uploaded last time, so it uploaded the FIFA wala data. No problem. So I need to give that file name here, bank-2.csv. Perfect. So guys, whenever you upload a file, I told you this is how you read it using Spark session to create a Spark data frame and then display the data. So for every person, you have his age, his job, his marital status, education, whether he's a defaulter or not, he took a housing loan or not, he took any loan or not, do we have his contact info or not, some kind of information we have for this particular person, and whether he will take a deposit or not. So that kind of data we have. Please confirm me if all of you have the data loaded.
Sir, can you please send us the command of just uploading the data frame?
Done. Please run this. So guys, please confirm once you have loaded the data and you have seen the data. Perfect. So whatever file you had, you uploaded it, you read it into a data frame and you saw its data using display function. If you don't want to use display function, you can use if you don't want display function, you can use data frame dot show, which is another function which also displays the data like this. Perfect. So now we have the data available with us, but there is one important thing I want to tell you now. You saw that a table also get created, right? Parallelly, a table also get created. So guys, that table can directly be referenced here. Whenever you upload a file, a table automatically gets created in Databricks. So write %SQL and let's say select star from, I gave the table name as bank. So it selects star from bank. Right, what happened? Table or view is not found. Why?
First, we have to create the temp table.
No. What I am saying is, see,
Its name was, I guess, bank info.
Bank info. Very good. It was bank info. Very good. See, what I am saying, Pankaj, is I was uploading, whenever you click on create table and you upload any file, whenever you upload any file, let's say this file, there is this create table with UI. Click on that, select the cluster. So the good thing about Databricks is it also creates a table parallelly for you. Give the table name as something. I gave bank info. Now let's say I'm creating a table as bank 1 in this particular database, default database. My first row is the header. Let's say I infer schema so that data types are not string, rather they will become int. I infer the schema from the data that if data contains int, we'll make it int as a string and then create table. So this is like Hive table. So we are creating sort of a Hive table. See, it's getting created, it's done. But Spark does not have anything like Hive. So it's Spark's data lake. This is known as a Spark's data lake. Spark has its own data lake or delta lake where it keeps these tables. If you go under data, you see this databases. In this databases, you can see the tables, bank info. So these are the tables. So you can directly work on the tables without creating data frames. So I hope you are getting my point, Pankaj, that for every file that you upload,
Yes,
you
sir.
have a table also created automatically. But if you don't want to use that table, it's fine. You want to do some operations on this data frame. Let's say you want to draw few columns. And after that, if you want to create table, you can create that temp table, create or register temp table. That's a different thing. That is when you are creating a temp table. One is system is creating automatically. Another is you also can create using those commands, which we saw, right?
Yes, sir.
Okay. So we have the data. This data contains X also and Y also. This is our Y. This data contains train data also and test data also. So we have to split it into test and train data. We have to take X separate and Y separate. All these things we have to do. But before that, you also need to do feature engineering, because some of the data contain values as married and single. We need to make it 0, 1, 0, 1. Label encoding, right? Label encoding. We have to do all these things. We have to see the correlation plot, heat map, to see which columns are important, which are not important, and drop the unnecessary columns, right? I'm not going into all these EDA here. I'll do limited EDA, not detailed EDA, because you already know what all can be done in EDA. But I'm telling you, let's say what I would like to do is, I'm only interested in the first 4 columns. I'm only interested in the first 4 columns based on my correlation analysis. And I only want to keep these 4 columns and drop rest. And for these 3 columns, I will do the label encoding. So that's what we will be doing. Okay. So guys, now what we already have, we have a data frame, right? Let's see. We already have this data frame. Now what I want from this data frame, I only want to select few columns. How to do that? This is very interesting. Data frame also have its own programming language known as DSL. Data frame has its own language known as DSL, domain specific language. What I mean to say is this. I'll tell you 1 minute. See, data frame has its own functions, like RDD has its own transformations and actions. Data frame also have some functions known as DSL functions, domain specific language. From this data frame, you want to select few columns like age, job, marital status, and education, and want to load into a new data frame DF2. Okay, and let's see DF2. So we got the data frame, the required data frame. So please follow along with me. Please follow along with me. I'm pinging you command. from the original data frame that you created. You may done some heat map, correlation plot, right? And you found only these 4 columns are needed. So you just selected these 4 columns. This is something like SQL, but this is not SQL. Huh? This is a DSL. So please confirm if you are all done. And if you want to see, you can say df.show. Now we have to do label encoding. Right? We have to do label encoding. So for label encoding here, wait, huh? You have this data. Yeah, so you have to do label encoding. So for that, here we have something known as string indexer. We will see it now. So we have something known as string indexer. So we will be using string indexer, which is nothing but label encoding. So let's do this. We need to import string indexer also. So before we do this, let me import it. Always do imports in a separate cell and programming in a separate cell. So you want to import PySpark, not needed, leave it. From PySpark.ml, you want a pipeline. If you want to create a machine learning pipeline, it's fine. Here we are not creating a pipeline. What we are doing, we are interested in feature engineering. So from PySpark.ml.feature import string indexer, which is nothing but label encoder. Vector assembler is also very important. We will talk about that in a while. So label encoding is first we need to do. This again is not needed for you. You can ignore this. So how string indexer works? Let me first import the string indexer. Done. So a string indexer just needs the input column and the output column. Okay. Okay, there is one problem that I dropped the target column. So I need to have target column also, no? Target column should also be here. I think that was deposit. Target column, I dropped it actually. So that should also be here, deposit. So what I want to do string indexing for these 4 columns. So I will do one by one for each. So I'm saying string indexer input column will be deposit and output column should be label. Fit on this data frame df2, transform this data frame df2 and display df2. Let's see. I'll explain you this one. So df3. Okay. So guys, see how you do label encoding here or string indexer is. To the string indexer, you have to tell the input column name and the output column name. Like after indexing, what should be the new column name? Then you have this string indexer object. You will use a fit function and a transform function on the original data set, df2. So your original data set was df2. The problem is string indexer needs to run one by one for each column. It don't run for all the columns together. So firstly, what we did, we say for the deposit column, for the input column deposit, give the output column label, which is this. It's a string indexed, right? Label encoded. So same thing, we will do it for all other data sets. So we got df3. Now we'll transform the df3, and in df3, let's say the job column and encoded job column will be the output. Let's say encoded job column. You will get df4. Then on df4, I will use the marital column and I'll get E encoded marital column. And this will become D5. Then on D5, which is another column, education. So I'll pass education column here. And let's say encoded education column. I will transform D5 into D6. This is D5. And finally, I'll display D6. Let's see. So if you see now what I did, first I encoded this, then encoded this, then I encoded this, then I encoded this. So I get, for deposit, this is the label. And these are the other column, encoded job column, encoded marital, encoded education. So for the job column, we have values as admin, technician, service, like this. So let me ping you this command, this program, and please run it. First, import the string indexer or the label encoder. You can do even one-hot encoding also here, but I'm not doing everything. There are too many things. It will be a very lengthy course otherwise. So like we are doing label encoding, we can do one-hot encoding also, but we are sticking to label encoding. So we are doing label encoding for each column one by one, and we finally got this. So please confirm once this is done. But anyone having any doubt that Rahul, what have you done? I hope everyone is clear what I'm doing.
So every time you have to do it one by one.
Yeah, I have to do it one by one, right? First, I did it for the target column, and for target column, I have given the name as label.
Like when we used to do in Jupyter Notebook, we use a while loop for loop. Sorry.
You can do that here also, because here I had only 4 columns. I did it like that. But if you had 100 columns,
Yes,
definitely you have to do it through loop.
Okay.
But as I told you, this is a very compressed version of the teaching, because I'm not teaching you machine learning with Spark. I'm teaching you how to use machine learning with Spark. I hope you're getting the difference, right? I'm not teaching you machine learning here. But yes, you are right, absolutely right. You can do that for loop wala thing also. Okay, so string indexer is there, one-hot encoder is there. There are multiple such things. So please confirm once you have this data. Okay, guys. So if it's done, so you identified that, okay, which are the important columns. One more thing I would like to tell you that even you can use some of the Python packages here also. Matlab, if you want, you can use feature engineering through Python also. Okay. If you want, you can do feature engineering through Python's package also, sklearn package also here. But the problem is, whenever you will be using sklearn package here, that will fetch that data from all the machines on a single machine and run the program on the single machine. Getting my point, guys? What I'm saying is, let's say you want to do correlation analysis. You have the data split it across the nodes. You say, Rahul, I will use sklearn's correlation plot. Yeah, you can do that also here. But in that case, all the data, let's say data was on these three machines. It will come on one single machine first, and then program will run on that single machine. So you will lose the distributed nature of the program. It's not that you cannot use standard Python or sklearn. Here also you can, but every time the data will be collected on a single node and run on a single node. So you will lose the distributed nature. Okay. So sometimes if you have something that can only be done through pandas, you can do it, no problem, but you should know the issue with that. What will happen? Okay. So now we have identified the important features. One second, we have identified the important features. We have collected them, we have label encoded them or one-hot encoded them, whatever. Now we have to drop these columns, guys, right? All these columns, the job, marital and education column. So how to drop them? As I just told you just 1 second back, df6, now this is df6 dot select. So in the select list, pass which all columns? Age column, comma, you don't need job, merit, or education, you don't need deposit, you need e-job. So you will need e-job, you will need e-marital, you need encoded education column, right? And the target column should be at the end, which is label. So guys, there is a reason why for deposit I don't say e-deposit, I say label, because Spark says that target column name should be label. Okay, so that's why I'm keeping it at label. So this is target column name and this is features. So let's load df into df7. See, so guys, remember that data frames are immutable. Immutable means they cannot be changed. df6, I am never changing a data frame. I'm always creating a new data frame because original data frames are immutable. You cannot change them. Same is the case with RDD. RDDs, data frames in Spark, they are not mutable. You cannot change them. That's why if you want 5 columns out of it, just select 5 columns and create a new data frame. You cannot say df6, like select from this and load in df6. No, because data frames are immutable. The RDDs are also immutable. It is done, but ideally it's having a problem. It should have failed. Leave it. Getting my point? RDDs, data frames, they're immutable. You should never change them, like never assign df6 to df6 back. Always create a new data frame, which is df7. Okay. And now df7 dot show, see the data. This is one of the very important properties of Spark, that RDDs and data frames are immutable. So this is the final data, guys. This data is now ready to go into the machine learning model. But wait, still there is one more step. Let me take this data. Let me take a few records and put it here. This is something very important which I'm telling you now. Guys, see, these are the feature columns, right? These 4 are the feature columns. All of you agree?
Yes, sir.
Very good. So let me do one thing. I am taking the label column out. So normally, if these are your feature columns, normally this is how you pass it to the system. What these are known as, these are features, right? Features. Feature 1, feature 2, feature 3, feature 4. But Spark does not understand 4 columns. Spark says concatenate all of these into one single column. So you need something known as feature vector. So this is the most important part in Spark. All the columns that you have, they cannot be 4 or 5 separate columns. They should become one single column. That means I will be applying something. I'll tell you. This data will become something like this. Sort of a tuple. You can say it's like a tuple column with value 59, comma 3.0, comma 0.0, comma 0.0. So this is the first value. Similarly, the second column, what is the value? 56, comma 3, comma 0, comma 0. Are you getting my point, guys? Here, what I'm trying to tell you?
Yes.
That all the columns, all the feature columns that you have, they need to be converted into one single column known as a feature vector. So Spark only understands 2 columns. One is the feature vector and one is the label. So Spark says, pass me only 2 columns. One is the feature vector, which contains all of your features. And second is the target column, only 2 columns. So we have to concatenate all of these columns into one single column, so that we have only 2 columns with us. So now all these 4 columns, we need to concatenate into one single feature vector. And this is separate. That's why its name is label. So now I need to concatenate all of these 4s into one single feature vector. So for that, what I need is vector assembler.
Sir,
Assemble.
question hai.
One second. No? Assembler means assemble all the features into one single column known as a vector column, feature vector. Yes, please tell me.
सर आपने बोला कि डेटा फ्रेम्स इम्यूटेबल हो.
Correct.
तो सर जैसा बहन ने बोला अगर फॉर लूप चलाना है तो सर फॉर लूप तो चलेगा नहीं क्योंकि डेटा फ्रेम का हमारे को नाम भी तो चेंज करना है उसका ऑब्जेक्ट नहीं.
Very good, very good. I had this thing in mind. I don't want to go into that, but let
सर
me.
इंडिविजुअली करना पड़ेगा.
नहीं, इंडिविजुअली करना तो पड़ेगा, बट आप फॉर लूप से भी कर सकते हो. मैंने शायद लास्ट क्लास में भी ये चीज सिखाई थी. एक सेकंड, जब जो मतलब दूसरे ग्रुप में, आपके ग्रुप की बात नहीं कर रहा मैं. जब हम ये चीज कर रहे थे तो हमने फॉर लूप से भी किया था. देखता हूँ मैं इसमें है कि नहीं. हाँ, what I want string indexer. ये देख रहे हो यहाँ पे, ये एक फॉर लूप के थ्रू हमने किया हुआ है. बट थोड़ा आपको समझना पड़ेगा फिर इस फॉर लूप को अच्छे से.
छोड़ो सर.
नहीं, मतलब व्हाट आई एम सेइंग इज कि वो किया जा सकता है. मतलब बात ये नहीं कि नहीं किया जा सकता, कर सकते हो, बट उसके लिए बस थोड़ा सा आपको ये समझना पड़ेगा खुद से. ट्राई टू अंडरस्टैंड. बट माय पॉइंट इज, सी उसने एक लिस्ट ऑफ कॉलम्स बना दिया सबका और सारे को एक लूप में डाल दिया. फॉर I in this list, first it will run for this, then this, then this. So that's how it can be done. There is one hot encoder also, if you see here. So everything is possible, but you have to apply something. But yeah, you have raised absolutely correct point. Yeah, because of that nature of immutability, आपको हर बार उसका नाम logically change करना पड़ता है.
सर रियल टाइम सिनेरियोज में इंडस्ट्रीज में मशीन लर्निंग स्पार्क पे करी जा रही है फिर पाइथन.
It depends. ठीक है, कंपनी टू कंपनी. mostly people are moving to Spark. People are moving, I'm saying. They were not on this PySpark, but people are moving to Spark. I know most of the companies have already moved. Now companies are giving two options. You want sklearn, you do it. You want PySpark, you do it. They are giving both the options. But I'll tell you, I have friends who worked on Java machine learning, Java for machine learning using Mahavat. I myself worked on it. So we did distributed machine learning using Mahavat also and using PySpark also. So it comes from company to company. Most of the companies are already using PySpark for machine learning. So to answer your question is, majority of the companies have moved to PySpark for machine learning in real world. Okay.
Okay, sir.
So majority of the companies have moved to PySpark.
We can also do this deep learning on PySpark.
Yes.
Okay.
Limited. It does not have that advanced. Maybe you have CNN model, but it may not have all the advanced CNN models. It has CNN, it has RNN, but it may not have the advanced CNNs and all, right? They are working on it. It will come slowly. But you have perceptrons. So you have multi-layer perceptrons, okay? So you definitely have multi-layer perceptrons available. You can go through them. Okay. Okay. You did on this and then that. So now we have to use vector assembler, as I told you. So what is our data frame? DF7. So on DF7 we will be doing vector assembling. Let me check where is vector assembling. So now we will create a vector assembler, and to the vector assembler I have to give the list of the columns that needs to be concatenated. And again, features is the name of the target column. You can keep that name as features. So here I will have what age. Yes, age was needed. I should not change this. Definitely I should not change this. I should be, where is DF7? Yeah, here is it. Yeah. So what I will do now, I'll say, hey, vector assembler, please assemble these columns into the single column, and then assembler dot fit and transform that data set, which is DF7, okay, to DF8. Let's put it to DF8. Okay. And the column names for me is what? It's age, job, marital, and education. Job, marital, and e-education. So I don't want to concatenate label column, right? I only need to concatenate these four, correct? So I'm just creating a list of these four columns, passing that list here. So just create a list of the columns, pass it here, it will assemble those into DF8. So vector.
So column name is e-education.
Okay, thanks a lot. Thanks a lot. It's done. So okay, one another important thing I would tell you. When you say df8.show, you should write it in a separate cell, not in this cell. Can anyone tell me why? Can anyone tell me why I am saying df8.show in separate, not in this? Guys, because df8.show, I may have to run multiple times to see what the data is. But if I write it here, and if I run this cell multiple times, every time my vector assembler will run, my Spark jobs will run. Getting my point?
Yes, sir.
I don't want to run this cell again and again. No? Once the vector assembling is done,
Yes, sir.
I may say, okay, dot show. I may say, show me the first few columns, or I may say, hey, please display. So I can display the data in multiple formats. First 8 rows. So why to do that again and again? It will run again and again this cell. No? So remember these small things. Now guys, see the feature vector. This is how your feature vector looks like. It's an object of type vector, a dense vector, length 4, because there are 4 columns in it. Value is, it's like a list, 59300. Getting it? So you get a single column of the type vector. Now what we need to do, we need to drop these 4 columns, guys. We don't need these 4 columns, right? Because they are already in this features column. We have already assembled using vector assembler. So on df8, now I will say, hey, df8, please select only 2 columns. One is the features column and another is the label column, and put it in df9, immutability. And again, once I do this, I will say df9 dot show. So you have guys, it's like a key value. Remember from the Hadoop days, everything was key value. That key value is still very important. So this is like key and this is like value. So this order is also important. First, you should have features, then you should have labels. So if you look above, label was here, features was here. But when I selected, I say, give me features first and labels after that. This order is also important. So you have a feature vector. Now this is a feature vector. And this is labels. And the column names are also important. This should be this only. Any question before I move ahead?
No, sir.
Now we are ready to select whichever machine learning model we want because we have the data ready. So let's
Sir,
see.
एक बार हम भी कर लें.
हाँ, ये नहीं किया ना. कहाँ तक किया था आप लोगों ने?
सर वो लेबल एनकोडिंग तक करा बस.
नहीं, लेबल एनकोडिंग में भी. अच्छा, इसके बाद से वो ड्रॉपिंग नहीं की कॉलम्स की ना?
कर ली सर, ड्रॉपिंग भी कर ली.
वेक्टर इंडेक्सिंग होती है.
क्या सर डीएफ10 से भेज दो ना.
ये वेक्टर assembler रह गया.
Yes, sir.
Okay. Please do it parallelly. It's very important. And please do ask me. The good thing about few people is they do ask questions. Like Pankaj, Lokesh, Madhu, Adhyan, and few others. If I forget the name. So they definitely ask questions, which is good. Just do let me know, guys. I'm waiting. Once you are done, do let me know. Please do it and understand it properly and then confirm.
सर कोई DF9 वाला कोड पूछना है
कौन सा वाला?
सर DF9 जिसमें
ये वाला?
अच्छा हाँ
दिया तो है मैंने, दे देता हूँ दोबारा दे। अच्छा शायद मिस हो गया।
मिस हो गया।
हाँ Lokesh, Shivali, is it done? Harish, Puneet, Poshin.
Yes, sir. Doing, sir.
Okay. Rasti, Sanjana.
Almost done, sir.
Okay.
Doing. I'm doing.
Shrikant.
Doing,
Shrikant.
sir. Doing.
Okay, okay. You are getting it, Shrikant, because I think you were not present in most of the classes. Shrikant, are you able to get it?
I'm watching recorded sessions from YouTube, sir.
Okay.
Whatever I missed.
Okay. But focus mostly on the Spark. Even if you missed Hive or Scoop, does not matter.
Okay.
But don't miss anything in Spark, because that's what is most important.
Yes, sir.
Okay, Mayank, thank you. Okay. I'll just wait for a few more seconds and then go ahead. Okay. Okay, so now once you have the data available in the necessary format, you simply need to pass it into the model, or you have to do train test split, whatever. So if you say that this data contains both train data and test data, you can do train test split. But if you say no, this is only train data, you don't need to do it. So it's up to you. So let's see what to do. Please use Notepad++, all of you, means please have Notepad++ available with all of you. That will just help you. So we have DF9. So in DF9, let's say we have to split it. So we'll go here and we'll simply split this data. We cannot use the scalars train test split. So we have here its own random split function. So on any Spark data frame, you have a random split function. It's a random splitter. Like you have a train test splitter. Here also we have a random splitter, 70 to 30% ratio with a seed 100. Seed is like random state. You had a random state or a seed, and that's it. We'll split it. Data is ready now. 70 to 30% ratio, trains to test data. Now you have to do what? You have to select the model. So let's say what you want to do. So let's do it one by one. So from PySpark, like you used to do from sklearn dot linear model, you import a logistic regression. From sklearn.ml, sorry, not from PySpark.ml dot classification, you import logistic regression. Okay, you can import any other model of your choice. I showed you how to check it. The list of all the models available in this package and list of all the models available in the regression package. So we use logistic regression. We create an object. Yes.
What was the short key, like control space for checking?
Yes. Yeah. If you have this control space,
okay,
you will get the list. If you type the first word, then it's better. You have linear support vector classifier, SVC model also you have support vector classifier, right? SVM, support vector machine. Now see, this is what I was saying, that in any model here, you have to pass the name of the target column, which is label, and the feature vector, which is features. Maximum iterations, let's say 10, 20, 50, whatever you want. You can pass other hyperparameters also, like regression parameter, regularization parameter, ridge, lasso, elastic net. So you can pass as any hyperparameter here that you want. Once the model is ready, you simply fit it on the training data, and then you sort of evaluate or transform it on the test data. So we'll do this later. First, just run this. So see, it's running a Spark job behind the scene. Since there were 10 iterations, so 10 Spark jobs, so anyways will run. The rest 5 must be related to something else. Okay. So first of all, you'll say, okay, from the classification, import logistic regression, pass all the hyperparameters, but this is most important, which is the target column and the feature vector column, and you just fit it. But once you fit the model, it learns something, right? Once you fit the model, it learns certain things, as in certain hyperparameters. So no, not hyperparameters, certain coefficients and intercepts, that kind of things, right? So LR model, if you go to LR model, your logistic regression dot fit, once this model is trained, you get some coefficients, intercepts, they are trained, right? So if you want to see those things, let's check what all we have here. Let's see the coefficients. So we get a list of certain coefficients, as in there were 4 input features. So this must be something like, for each, what is the coefficient, right? In the same order, age, maybe marital status, job, and education, whatever. So the coefficient for all the 4 input features. Getting my point? Anyone having any doubt in this? That Rahul?
So we don't have to use the train test plate thing.
You did it already, no?
So, but okay, it's okay. Done.
Whatever data you had, you split it into train test data, but further you don't split it into X and Y here.
Okay, so that's.
You don't split it into X and Y here because you are specifying here what is X and what is Y, no? So it automatically identify based on the column name what is the X and what is the Y, because only 2 columns, right? So you don't split it into 4 parts like you do in sklearn. Train X, train Y, test X, test Y. No, you split it into train and test only. That's it. Even in R also you used to do that, right? In R also we don't split data into 4 parts, only 2 parts, right?
Yes,
The
sir.
train and test. So it's something like that only. It's in sklearn only that we split it into 4 parts. Okay. So model is trained, it has certain coefficients. This is the trained coefficients. So you can see which is more important. This parameter is more important. The third one, let's see, the third one was what? Where we concatenated this. I think if you look at here, marital status is more dominant in deciding whether someone will open a FD or not. Strange. But that's what the data is anyways. So marital people becoming more responsible and opening the fixed deposits as compared to others. Or I should say, means, yeah, marital column is one of the important indicator, whether someone will open it or not. Okay. But there are other parameters also. Let's look at that. Guys, understand one important thing, hyperparameters versus parameters. Hyperparameters, we have like maximum iterations and all. But what these are sort of parameters. Like coefficients are parameters. Like what are learned after the training phase. These are your parameters. That model is learning some parameters. Model is not learning hyperparameters. Hyperparameters are passed in the model and output is these parameters, which are your coefficients, intercepts, that kind of things. Okay, so guys, understand this again. Currently, we have trained the model, and from that trained model, whatever is the trained model on our data, we are just checking its features like coefficients, intercepts, right? Let me print this, coefficients, and let's say I also interested into intercepts. So here I got the coefficients and the intercept, because logistic regression behind the scene is a regression model only. So it's like a linear equation for that model. It further applies a sigmoid function on a linear equation. That's a different thing, but this is the linear equation behind the logistic regression. And once the model is done, you have a summary of the model. The summary of the model contains its accuracy and area under the curve. Trained model, okay, this is not a tested model, trained model. 53% is the accuracy. Area under the curve is also somewhat closer to accuracy only, not same. So it's 56. So it's a very bad accuracy, I would say. But let's see how can I improve it. Can we improve it by playing with some hyperparameters? I'm increasing maximum iterations, let's say to 50. And I'm doing some regularization, okay, of elastic net types with 0.09 as its degree. It will take more time because 50 iterations internally. So it's 16 cycles only ran. Let's see whether any improvements.
16 cycles only run shopping करना चाह रहे हैं.
Let's check this.
Sorry, मुझे समझ नहीं आया.
Oh wait, my Alexa actually started to talk. 1 second. I don't know. I must have said some invocation word, so she got started asking me questions. Okay. Yeah. So here, if you see, even there is no improvement. There is no improvement even after playing with these hyperparameters. Let's see if I can include some other hyperparameter. Maybe like learning rate alpha. So the problem is it's not showing me all the hyperparameters, right? So what I will do, I'll go back to where is the model? Where is the model? Where is the model? 1 minute. Yeah, here is the model, right? So if you remember, I told you in the lr.params, it tells you all the hyperparameters. Let's say you want to play with elastic net parameter. You want to play with some other parameter like maximum iteration. So it's just explaining me those parameters. I'm just looking at it. 1 minute, if any parameter can be changed. No. So you have to look at the hyperparameters. So these are, now I'm looking at the hyperparameters like elastic net parameter between 0 to 1. For alpha is equal to 0, the penalty L2 for alpha 1, which is L1 penalty. L2 and L1. So let's look at what all parameters we have. We have threshold in the binary classifying in the range of 0 to 1, threshold. Okay, no, that's not needed. Bound. So we haven't done any standardization in the data, right? So if you look at the problem, the biggest problem with my data, if you look at the biggest problem with my data is the range of the columns. Everything should have been in the range of 0 to 1. So I didn't do any scaling, right? Which is another problem. So let's scale this data, right? So we need to scale this data. So either I can do standard scaler, or there is this option standardization, whether to standardize the training features before fitting the model. So let me say, hey model, can you do it for me? Where is the model? And I don't know what the value it expects, but let's say true. Standardization. So I'm saying model, please, can you standardize the data as well? One second. Let me check. So these things are trial and error, right? So you have to do this a lot.
So can we increase the accuracy by adding columns? Like we drop too many columns.
Absolutely. I drop them randomly.
Yes, sir. That's why accuracy is maybe low.
Yeah. But I'm just checking what else I can do. Standardization is equal to true. Okay.
सर छुट्टी कब होगी?
बस 5 minutes. At 2:30. Okay, this is done. Okay, anyways, you try it more and see what you can do. Try to include more columns and then do it. So we saw that, okay, we got the accuracy. Now simply go to this. The next step, which is testing the model, which is like passing the test data and transforming it. So once you transform it, you get the predicted output. Okay, you get the predictions on the test data. So you have the predictions ready now, means on the test data, you did the predictions. So let's see what the model predicted. So model, okay, it's a feature vector, it's a label, it's the raw prediction probability. So guys, see, once you pass the data, the test data to the model, it do the prediction, which is a data frame, another data frame. So put a show on that, and it shows you that for this input feature, this was 1 second. Okay. It's showing only 3 columns. I think one of the column is of no use, so it's not showing it maybe. Then it's showing you the predictions. So this label is the actual, this is the actual value. Okay. And prediction, this column is the predicted values. So if you see, this model is not that good. It's predicting 0, 0, 0, 0 mostly. There is this raw prediction and the probability. So again, we say that, okay, probability above a particular value, whether it becomes 0 and 1, like that. So this is the raw prediction and this is the actual prediction. Just forget about this raw prediction and the actual prediction. So anything below 0.5 is 0. Everything below 0.5 is 0. So it actually predicted everything as 0, which is not good. But anyways, that's fine. So this probability column, if you want to look at, you can definitely look at that also. Display. What the probability column says is, if this is 0, this is 1. I hope all of you know probability of belonging to the class 0 and the class 1. So probability belonging to the class 0 is 59%. So it's 0. Right? That's how it works.
Can we change here also the threshold value? Like by default, it's 0.5 now, so we can
Yes.
adjust it.
Yes, you can do that. When you are doing the training, if you have seen it, there was a parameter threshold, right? There is a threshold parameter, right? You need to look at, I think there must be a threshold parameter which you can check. Setting the default value for the threshold parameter, how you can do it. Okay, so now what you have done the prediction, you have the predicted output. But now we have to just create a confusion matrix, sort of, to check the final accuracy, how accurate the predictions are. We saw the training accuracy was 56 or 53%. But how is the test accuracy? So for test accuracy, you have the data with you. So you have the actual predictions versus, sorry, you have the actual values versus the predicted values, actual versus predicted. So you can create a confusion matrix and check it. In this case particularly, everything is 0, which is not good. But let's see what you have to do now. Once you have the actuals versus predicted, you simply use RMSE, MSC if it's a regression model, or AUC, ROC curve, it's a classification model. So now we will be using the evaluation package, like from PySpark.ml.evaluation package. We have binary classification evaluator. We create an object of that and we'll say, hey, evaluator, please evaluate the predictions. Predictions as in this data frame. From this data frame, it automatically looks at this column and this column. You don't need to do anything. It automatically looks at this column and this column, compares them and tells you the output. Let's see this. 55% is the accuracy of the test phase, and 53 was the accuracy of the train phase. So this model is not overfitted. This is underfitted, right? This is an underfitted model, not an overfitted model, because its train accuracy and test accuracy are almost same. So it's not an overfitted model, it's an underfitted model. Getting my point? So tell me till what, so with this we are done, guys. Tell me till what place you have done so that I'll share with you the codes. You built the model or not?
No, sir.
No, sir.
We did vectorization.
Okay, you did till vectorization. Let's go ahead. This is the last thing for the day. Let's please complete it. Split it.
Can you publish your link? It's simple.
It will become difficult because there are a lot of other codes in that. That's why there are a lot of other data sets in this notebook.
इसके लिए publish कर दो.
So just run this, please, one by one.
Is there any code for the confusion matrix also? Like that we can
Yes.
see all the recall and sensitivity.
Yes. I'll see if I can in the limited time, but first priority is please complete this, then I'll see if I get some time. But this is first, complete this first. Can I move ahead?
Yes, sir. Done.
Okay, perfect. So what I'm saying is,
Sir,
if you
error
want-
आ रहा है.
1 minute. If you want, you can use decision tree classifier also. Same way, just the model will change. That's it. Some hyperparameters will change. But the good thing is, once you fit the model, you can use display function, and you can display the graph also, how it looks like. क्या error आ रहा है आपका?
सर स्क्रीन शेयर करूं?
1 second, लोकेश. शेयर करो. Label does not exist. Available features e deposit. हाँ देखो ना, it's saying that the label column does not exist, right? And I told you that it always looks for the label column. It's saying the available columns are features, e deposit, raw prediction, probability, and prediction. So you have the column as e deposit. So the label column name is e deposit. So no problem. Are you getting my point? Instead of label, your column name is e underscore deposit.
Yes, sir.
Okay. So go above. See, your e deposit is the column, na? Okay. Go above. Where have you created this e deposit column? Go up. That's it. Yeah, here we have. Okay, scroll up. Okay. So ideally you should have made it label from the starting, but no problem. That you can do on your own. But let me solve it. Go beyond. Go below. Let me solve it. How can we do it? So when you are saying evaluate predictions, then there you have to pass the feature column and the label column. Okay, 1 second. Give me 1 second. Ideally you should have changed it, but no problem. I'm telling you the answer. You have to just pass few additional parameters. Okay. In the binary classification evaluator object that you created, no, line number 4. Yeah. Here. Here you have to say, write label call equals to, within double quote, e underscore deposit. Okay. Give me 1 minute. This is what you have to do, but I'm just trying to check the API reference of PySpark, whether this is what I have to do or something else. Binary classification evaluator. I'm just checking its source code. मिल गया. Got it. Label call. Make CS capital in the label call. Run it.
Okay, sir. Thank you.
So you got the issue?
Yes, sir.
Okay, let me share the screen. See, I myself don't know the answer to your question, okay? But what I did see, the similar way where I told you to go inside the actual, I went into the actual code of this evaluation function. The evaluation function that you're using, I go into the PySparks website in the Sparks documents, and there I searched, hey, the evaluation function, I need to check in the constructor. See here, label call is always as a label word, but if you have some other word, you have to pass that here. Okay, getting my point?
Yes, sir.
This label call, I'll ping you this link. You can go through it. You should know how, what to check where. You don't need to remember everything. Okay, one second. But you know that you could have solved that by even keeping the name as label in the starting, right?
Okay, sir.
In the starting also, you should have kept it as label instead of e_deposit. Okay, I think that's it, guys. You evaluated the model, and you are able to check the accuracy of the model. So what you do, maybe logistic regression is not good, so you use a decision tree. Where is it? You can use decision tree, pass on some depth, fit it on the same data, and check it. Let's say what I have df9, right? Df9 was my data, so let me do it here. The same data now I have passed into decision tree. Okay, and this DT model, the DT model that I have, if I check its summary, hey, what happened? There is no summary. Anyways, let me try to display that and see. So this is how my particular data set goes. Feature 0, the 0th feature, then it again split it on the 0th feature. 0th feature was the age, so it goes on the age. Then feature 2 it used to split, and then this is how it's using feature 1 here. So feature 0, 1 and 2 is used, feature 3 is not used here. There were 4 features now, so that is 4th feature is not relevant, I think. Number of nodes are 9 and depth is 3. Where is it? Depth 3. So let's say I'll say depth as 10. Let's see. It will take some time to train it. 10 depth model will be a very big model. 419 nodes. So what I'm saying is on a decision tree, I increases the depth and then fitted the model, and then I'm checking the model's number of nodes and the depth, and also let's display the model. This model is becoming quite huge, quite big and a complicated model, not even understood here, but this model may have better accuracy. Let's check that. Oh, I did one mistake. I passed the df9. I should have passed what? Train data, because I have 2 columns, train data and test data. What happened? Training data. It's not train data, it's training data. training data. So I passed it on the training data. Earlier I passed it on the full data, which was the mistake. I should pass it on the only the training data. Once that's done, I'll simply transform it on the test data. I'll show the predictions in this case. Let's see. Even in this case, if you see, everything is sort of a 0, so which is not good. If I evaluate it, earlier it was 73% accuracy. Let's see now what it is. 48. So definitely it depends, because I have dropped a lot of columns unnecessarily. So this issue is because I have dropped some of the important columns from the data. That's why even decision tree is not able to give me a good accuracy here, for that matter. Okay, so that's it, guys. You can try grid search CV also. I'll publish this notebook, but you have this notebook contains 2 data sets, so you have to accordingly look at it. There is grid search CV also that you can do using parameter builder and grid builder and the cross validator, so you can do that. And someone was asking about the confusion metrics. So for confusion metrics, what you can do, you can use sklearn if you want. So guys, just give me one more second, because someone asked, so I want to show that. Where is logistic regression? Here it is, right? Yeah, so we checked the area under the curve, but let's say okay, you also want to display confusion metrics. Okay, so what I have my predictions. Let's say, do I have predictions? Yes. Yeah. So for this thing, once you have the model, you evaluating it through all those things and this. So for the confusion metrics, you need only these 2 columns, label column and the prediction column, right? I think Adhyan or Mayank who was asking this, label and prediction column. So simply go to sklearn. I'm going to sklearn for confusion metric, sklearn confusion metric. So this is what I need. I just need this command, which is over here. This is the one. That's it. So go back here and create a cell. Okay, where is it? Put it here. From sklearn.metrics, import the confusion metrics. Okay. Done. sklearn is already available here. Okay. Otherwise, you have to do pip install here. Huh? You can do pip install also here. So from sklearn.metrics, import this confusion metric, and then let's say someone from you wants to do this confusion metric dot sorry, not dot, it's actual versus predicted, right? So where is my prediction column? You have predictions. Okay. So I need the label column and I need the prediction column. So here you don't do it like this. Like this, you cannot access columns like this because it's not a pandas data frame, right? So what you have to do, remember, select. I told you this. You have to use a select command to select the column that you want. Getting my point? Select column. So if I only do this label column, I show you. So this is the label column, right? So it's not a pandas data frame, because if it would have been pandas data frame, you can access a column like this also, right? I think like this, right? Guys, yes or no?
Yes, sir.
If it would have been a pandas data frame, you could access even it like this. You can access it like this also, right?
Yes, sir.
But no, you should not do that. You should use this because it's a Spark data frame, and in a Spark data frame, you have to use select function to select a particular column. Okay. So go to the confusion metric and pass the columns. This one, comma, the actual versus the prediction column. Like, okay, expected sequence or array like and got something. Yes, very good, very good. Guys, what is happening is the confusion matrix does not understand Spark data frames. These are Spark data frames. Confusion matrix is a sklearn function, right?
Yes, sir.
And to the sklearn function, the confusion matrix function, I am passing Spark data frames, right? So I need to convert them into pandas data frame. How to do that? Import pandas as pd dot data frame, and then pass this here to, let's say,
So D and F.
so guys, those of you who wants to drop, they can drop because I'm just doing some additional stuff because few people want it. So I'm just doing it for them. If you want, you're welcome to stay. Oh, okay. I see my mistake. Unless I don't show, how will the data will be there? I need to show the data, na? Then only the data will be there. So I need to put a show here. Perfect, it's done. So what I'm saying is, from this data frame, I only selected a particular column, but still it's a data frame, Spark data frame. And when you show, then only the data will come because Spark is lazy, right? We have to show or collect to see the data. So that data now got converted into pandas data frame A. And let's say I have to have B also. In B, I will have the predicted column, the prediction column. So now A and B are my pandas data frames now, so they can be passed here in confusion matrix. I cannot pass Spark data frames. I can pass A and B here. That's fine, we will solve it. But now error is different. Unknown is not supported. So in A and B, unknown is not supported. What is unknown? So anyways, leave it. Let's not make it complicated. What I'm saying is, from sklearn.matrix, you can use confusion matrix. But in confusion matrix, you cannot pass a Spark data frame. So you have to convert it into pandas data frame. I did that. That's it. Then I pass A and B to, where is that? Confusion matrix. That's done. Unknown is not supported. No metric support multi-class, multi-output format. It's only zeros and ones. It's a binary one. Check targets. 1 second. Okay, see, A does not contain any data. 1 second. What about B? Oh, they are not loaded. Huh? See, they are underscore. They are not loaded. Why?
Sir, can you use show command with this b dot show?
1 second. Let me check the type of B. Pandas data frame only. 1 second. See, there are multiple ways of doing something. It's saying use two pandas function. Huh? So let's see if there is a two pandas function. Let me check. What we did was also correct. There is nothing wrong, but data is not loaded. Huh? So what I'm doing another way, which is as per Google. That Google is saying, Rahul, please don't do this. It's saying, please do this rather. Two pandas. It's asking me to use this function. Okay, let's check. Let's see. So guys, what I'm saying is, this is also right. There is nothing wrong with it, but internally Spark and pandas may not be supporting this conversion. There's nothing wrong what we did. Otherwise it would have failed. Huh? But this conversion is not somewhere supporting data. It's getting loaded with blanks, nulls. That's why the error. That's why the error that we were getting, unknown not supported somewhere. The error was coming like unknown not supported. Leave it. But now using two pandas, yes, this can be done. So let's do it here. So A and B. So from this Spark data frame, I selected only the prediction column, another column, and I say two pandas. Huh? So above is also correct, but it's not loading the data. That's what I'm trying to tell you. I'll publish this notebook, no worries. Now I have A and B. Now it must work. Huh? It must work. कहाँ भाग गया भाई? Confusion matrix कहाँ चला गया? अब हाँ ये रहेगा मेरा बेचारा confusion matrix. Okay, so confusion matrix is printed. Guys, are you getting my point? A is to B. Who asked this question? Adyan.
Yes, sir. Yes.
Good, very good. So you can use confusion matrix, sklearn's confusion matrix A comma B, but you should understand that if you are using sklearn, you cannot pass Spark data frames to it. You have to convert it into pandas data frames, right? And then only you can pass. Can anyone tell me? Let me ask you guys. Okay, this is just the last thing. Let's say this is 1, this is 2, this is 3, this is 4. What does 1 indicates here? 12, 19. Can anyone tell me?
True positives.
True positives. What do you mean by true positives?
So the actually it was 1 and also the machine predicted 1.
Means yeah, this guy is going to take FD and we say yeah, it's going to be FD.
Yes, sir.
And what is this?
So
So,
negative.
yes.
What?
If he will not say, if will not take FD, and the model is also predicting that he will not take.
True negatives, huh?
Yes.
Yes, sir.
What is this?
What?
False positive, false negative.
False negative. False negative.
He is going to take FD, but model predict that he will not.
Okay, wait. Let's say he is. This is yes and this is no. And this is also, let's say, yes and no. Okay. This is actuals and this is predicted. Huh? Actuals and predicted. Yes is to yes, no is to no, it's fine. But yes is to no. Actual was yes, model predicted no. So what is that known as? False positive or false negative?
False positive.
Negative.
False negative.
Negative.
False
Did
positive
prove it.
or false? Guys, please ping me. Let's ping me. Whether it's false positive, this is false positive, false negative. Ping me. I want to see. Don't speak up. False negative means you are saying something. You are saying something, but actually that's not the case. Means you are saying no, but actually it's not no. So you are saying no, but actually it's yes. So false negative. Falsely predicting something as negative. So yours is not correct. So false negative is it's not negative, it's positive. Okay. So still, if someone wants to drop, they can drop. What I'm going to do next is just plot a C-bond on top of it. Just plotting a C-bond on is. Import C-bond as SNS. SNS dot heat map. See, so you can use pandas stuff and all mix and match, but whenever you are doing this kind of stuff, it's running on a single machine. It's not distributed. So this is your 0:1 and 0:1 actual is to predicted. Okay.
The Seaborn also runs on single machine.
Yeah.
Oh.
Seaborn is looking at this data. This data is already collected on a single machine. Okay, guys. So now Monday. So that's it. So you know that you can do a mix and match. So till Monday, practice as much as machine learning you want. Let me publish this notebook. This notebook contains 2 data sets, so you might get confused. So please have a look at it. It contains 2 data sets. Some other data set is also there. So don't get confused with that. I have shared this to all of you. Go through it. Come up with the doubts on Monday, and Tuesday will be your exam. Okay. So that's it, guys. This was the last class officially. Thanks everyone for your time.
Okay, sir. Thank you so much.
Thank
Okay.
you, sir.
You guys can reach out to me
Thank
whenever
you,
you
sir.
want, because today was the last class. But in case you need any future guidance and help, reach out to me. Okay. So after Monday's doubt class, you will have a written exam. After that, I will take one Viva, maybe on Wednesday or Thursday. That's it. Then you will have classroom classes for PGA12.
Sir, Viva will be on the Spark only or the whole?
Everything.
data, everything. Okay.
Everything. Viva will be on everything. Okay. So most probably Wednesday, Thursday, you will be done with everything from my side. Please convey the same to your friends in the batch, and yeah, do reach out to me. Thanks everyone. Bye. Take care. All the best for your career.
Bye.
Thank you, sir.
Thank you.